Hey guys, how are you doing? This is Arjun Sondhi, and let's continue with the theory of consumer behavior. So we ended up last time with finishing the theoretical part. Let's start with an example. It's the same parameters as before. So here's your budget constraint. You have good 1, good 2. Your horizontal intercept is 4 because your income divided by the price of good 1. And similarly, your vertical intercept is 2, which is where you consume nothing of good 1 and 2 units of good 2. So, and then you draw your budget constraint. And if you want to look at a combination where you want to consume a sum of both units, you can look at this option here where you consume 1 of good 2 costing you 10 and 2 of good 1 costing you 10 as well, leading up to a total income of 20. So every point on the budget constraint, A, B or C or any point in between those are efficient because you are using some combination of x1 and x2 and spending all your income. If you look at a point inside the budget constraint, so let's say we want to consume 1 unit of good 2 and also only 1 unit of good 1. If you do that, you see that combination, point D, is inside the budget line. Now let's look at these numbers here. That means you're spending 5 and 10, 15. So you are not spending all your income when you are picking a point inside the budget line. So the moral here is that when your parents give you your allowance for the week, you might as well spend all of it because you're not going to be returning it to them. All right, now let's look at a point outside this budget constraint. So if you want to consume, let's say, 1 unit of good 2 and 3 units of good 1, now that's not possible because you'll be spending 10 plus 15, which is more than your income. So just to summarize the numerical example here, every point on the budget constraint is A, possible, and B, efficient because you're spending all your income. Any point inside this line is possible, but you will be not spending everything. And any point outside this budget line is not possible given your current income. So that's how to look at it graphically, what it means. So today's part is going to be talking about what changes your bundle of x1 and x2. So now we are going to do what is called comparative analysis in economics, is where we change something here and see what happens in our model. So if I asked you, given these numbers, what might lead you to consume more of good 1 or good 2, what are 3 options that you can come up with? Right? So you have the model here. Think of 3 options that will change, that will then lead you to consume more or less of either of the 2 goods. So I'm sure the first guess is if your parents give you more money. That's obvious. That will lead you to buy more of x1 or x2 or both. The other thing is if prices change. If one of the goods become more expensive, then you have to make some choices of either consuming less of that or less of the other good. So that's what we're going to do in today's class, is to see how your decision making changes when those variable changes. So we are going to first start with changing income. So let's say income goes from 20 to 50, right? So that's how we write when something changes, is this is M and then that becomes M superscript 1. The prices are the same, so think about what that might lead to. I'll draw another graph here, how that might change your decision making. So think about it while I'm reproducing the same graph from there. So we still have the same endpoints, 4 and 2. This is your origin. So think about your vertical and horizontal intercept and how that might change when your income is 50 and the prices are the same. All right, so let's look at horizontal intercept first. Let me ask you, when your income goes to 50 and the price of good 1 is still 5, how much of good 1 can you buy if you buy nothing but good 1? So you divide 50 by 5, you can see that that number here is going to be 10. Similarly, if you want to look at the intercept on the vertical axis, I'm just going to expand that a little bit, you can see that if you spend nothing, everything on good 2 and nothing on good 1, you can now buy 5 units of good 2, 50 divided by 10, and that's going to be somewhere here. Now when you move this budget constraint out, you can see relative to here, now there are going to be more possibilities for you to choose between than before. What do you think happens to the slope of the line when income changes? That's right, the slope does not change because this ratio has not changed at all. Right? So P1 over P2 hasn't changed, so this line is going to move out in a parallel fashion. Similarly, if your income went down, if you misbehaved and your parents decided to give you 10 rupees instead of 20, now your budget constraint is going to go inward. Just to get an idea of how your budget constraint moves when your income changes. Now let's do one example with a change in price of good 1, and then I'm going to leave you with doing an example of P2, which I'll start the next video with. So let's say price of good 1 increases, right? So it doesn't matter whether we increase or decrease. Again, we are going to start off with the same starting point, which is 4 of x1 and 2 of x2, and we have that budget line, the slope of which is P1 over P2. Now think about, if price of good 1 goes up, what happens to this vertical intercept, which is how much of good 2 can I buy if the price of good 2 is 10. Let's go back to the original example of 20 rupees. That number still remains the same, right? That number is going to be 2. What about the vertical intercept? If the price of good 1 goes from 5 to 10, what happens to your total amount of good 1 that you can consume? That is going to now go down from 4 to 2 because of 20 divided by 10. So your new budget line is going to move in an inward fashion, where now you have fewer possibilities to choose from than before. So that's a couple of examples of what happens when M goes up or down, when P1 goes up. And then I'm going to conclude this video by asking you to do a problem before we get to next time, which is think of P2, and you can, let's say, decrease P2. You can pick a number, go from 10 to 5 or 10 to 4, it's up to you, and then graph for me how it will change in this space here. So hopefully you guys can do this before next time, and I will start next video by finishing this example and moving on to the next topic. All right, have a good day. See you next time.